Hi Math 1 students. This lesson is going to be on the translations of linear equations. I'm going to go through some notes, a little bit of review, and then an example homework problem. So first of all, what are the explicit forms of equations of lines that we've used? We've used three. One of them was the recursive form, but the two explicit forms are the slope-intercept form, which is in this form, y equals mx plus b. If you recall, m equals the slope, and b stands for the y-intercept. We'll look at an example of that. The other form is point-slope form. Again, m is the slope, and then the other thing that we have is this x1, y1. x1, y1 is a point on the line, or on the graph. And I'll show you an example of that. So our first one, let's say we have a line, we have either a graph that's drawn, we could get the slope and the intercept off the graph, or let's say we just have a line y equals, let's say 2x minus 1. Basically that tells us that our slope is 2, or has, rise of 2, run of 1. And then the intercept, the y-intercept, is actually -1. The sign has to go with it. Another way to write the y-intercept is to write it in ordered pair form. And if y equals -1, that means x equals 0. So it'd be 0, -1. In point-slope form, basically what you have is, you have it a couple different ways. Let's say you would get a point on the line. Let's say we have a point 3, 4. And let's say that we know the slope is equal to, let's say, 3. So we could build this equation of the line by saying y equals slope of 3, open parentheses, x stays the same, so the y and x without the subscripts stay exactly as they are. And then minus x1, so minus 3, close parentheses, and then plus y1, so plus 4. This is point-slope form. If you have negative values, let's do an example with some negative values in there. Let's say it's, let's just say it's -3, -4, with the slope of 3 again. On that one, we have y equals slope of 3 times x minus x sub 1. So it'd be x minus x sub 1 is -3. So it's a minus and -3. I'm going to fix that in just a second. And then plus y1, which is -4. So that turns out to be y equals 3 times x. This becomes, two negatives become a plus. And then a plus and -4 we could just write as minus. Now this can actually be converted to slope-intercept form pretty easily. Basically you just have to distribute. So you get y equals 3x plus 9, and then minus 4. Combine these two parts, y equals 3x plus 5. And that would be the slope-intercept form that is the same as that. So it's the same exact line, just in a written in a different way. One thing to remember on this that's pretty important is, this is a mistake that some students make, this last piece out here, you have to remember that that is not the y-intercept. In this form, -1 is the y-intercept, but this is a much different form. So you can't say that that is the y-intercept. Like, take a look at this one, plus -4, or -4, that is not the y-intercept. If you put it in this slope-intercept form, you see that the y-intercept is actually +5. So be careful about that. Okay, the next thing is I want to do some examples so we understand what a shift is in a linear graph, or in any graph for that matter. There's some other examples here that are certainly not linear. I'm not going to do all of these, but let's look at this kind of jagged graph. It says use the graph below to draw a new graph that is translated up 3 units. So just when we had rigid motion transformations, we're going to do the same kind of thing with lines and whether they're straight lines or jagged lines, graphs, let's say. When we translate something up 3 units, we're just going to go up 3, we can just count. Every point on this graph moves up by 3 units. So you could actually look at it point by point. So let's start with this point. I'm going to move up 1, 2, 3. That's the new location. Starting from here, move up 3, 1, 2, 3. That's its new location. And I'm going to keep going. 1, 2, 3. Move this point up 3. Move this point up 3. This point up 3. This point up 3. And then connect it left to right. Okay, so the whole graph moved up 3 spaces. So this is up means in the y direction. If you move this in the x direction, the shape of the graph is going to be the same. It's just going to be in a different location. One other thing to notice when we translate up, look at the y-intercept. Here the y-intercept was -2. Now the y-intercept is +1. And you can see that the difference here is 3 units. So it went from -2, add 3 units, ends up being at +1. So the y-intercept is pretty easy to figure out. I'm going to skip that one. Let's look at this number 3 here. We want to translate down 4 units. Okay, now these are just have some straight lines. There's not individual points like this. But you can just imagine a point. Here, let's say imagine this point right there that's on the graph. I'm going to move down 4. So the y-intercept is going to go from 0 to -4. And then just pick any other point that's nice. I'm going to pick this point. I'm going to go down 4. And then all these points will go down 4 also, but I know that this is just a straight line. So I can connect these and make that a straight line too. And I'm going to do the same thing over here. I'm just going to pick a point, and I'm going to go down 4 units. All we really need is 2 points, and I can connect those and make the picture. That is the translation. So it's down 4. Every single position has moved down 4 units. Okay, I hope that makes sense. Let's do another couple examples here for you. Okay, so let's say you've been given the equations f of x and a transformation, which is shown as g of x equals f of x plus k. K is the amount that we move in the the y direction. So if it's positive, it's an upward movement. If it's negative, it's a downward movement. They want us to graph both of these and then write a linear equation for g of x. So f of x is 2x minus 4. Let's draw that one first. It's just a linear equation. Easiest way to start here is with the y-intercept -4. It's got a slope of 2. Up 2 over 1, up 2 over 1. Get enough of those. And we can graph that. Now since we're going to have more than one equation on a single graph, I'm going to label it. So this is f of x. G of x is f of x plus 3. So that's basically saying it's this line plus 3 units everywhere. So I'm going to actually move every point up 3. 1, 2, 3. 1, 2, 3. I only need to do enough so I can get a good line. And this is g of x. So g of x equals f of x plus 3. But how would we write that? How about this? Instead of f of x, I'm going to write in this. So I'm going to just substitute that right in there. So this equals 2x minus 4. There's my substitution. And then plus 3. That's my translation. And now I'm just going to combine these. I don't have to distribute anything. I'm just going to combine these values. And I get 2x minus 1. We can check that. The slope is 2. We didn't really change the slant of this. And the new y-intercept is -1. and that is correct. So there is our new equation. So let's do another example here. If you want to try this on your own, you can, but I'm not going to do it in the video. Let's look at number 7. They want us to write an equation for g of x in the form g of x equals f of x plus k, then simplify the equation of g of x to slope-intercept form. They've given us equation for f of x. We need a new equation for g of x. They didn't actually tell us what k should be. I'm gonna just pick a value here. Let's say k equals 2. I'm making that up, so I'm going to draw my graph that way. So here we go. We have -3 is our intercept, and our slope is 1/4. That's going to be up 1 over 4. And I can't mark another one, so I'm going to go the backwards direction. Over 4 down 1. This is my f of x graph. I'm going to label it as f of x. And I want my translation to be positive 2. So I'm going to go up 2. That's my positive 2. And I'm going to do it at nice locations. See how these are not really nice intersections. This one is. So that makes it easy to count up 2 spaces. I don't want to try to estimate where 2 spaces up would be. I want some good points that will work. And those are good ones. So this is g of x. In g of x, notice here's a new term, translation form. Basically that's saying is g of x is the same as f of x plus 2 more. This is translation form, where g of x is some other function shifted by some amount in the y direction. So g of x, if I write it in slope-intercept form, g of x is going to be this, 1/4 x minus 3, and then add 2 to that. I can combine these numeric pieces, so g of x equals 1/4 x minus 1. I can verify that y-intercept. So there is slope-intercept form. These both have a slope of 1/4. So notice a vertical translation does not change the slope at all. Every y value changes by 2 points. If you want to look at what the x values change as, the x values in this case change as 8 points in the x direction. The reason why it's 8 is because it's 2 units in the y direction divided by 1/4. So it's 2 divided by 1/4, which is 8. We don't really need to worry about the x direction shifts right now, just the y direction. Alright, so the next thing that we have is homework. I'm going to I'll go through the workings of the first homework problem in my next video.